in the question, they have provided us a XT graph and they are asking us to verify which of the following options is correct. So in the XT graph, we can observe that they have given some points A, B, C, D, E, and they are asking us to find the relative options. So first, let us check option A. Option A says that the particle was released from rest at t is equals to 0. The particle was released from rest. What does this phrase mean? It means that the particle was started from rest at t is equals to 0. The particle was started from rest. This means that the velocity of the particle at t is equals to 0 was equals to 0. So in order, let us check whether at the point t is equals to 0, the particle velocity is 0 or not. If the particle velocity is 0, then option A becomes true. So we can observe that t is equals to 0 point lies on the displacement axis. So that is point indicated by point A. So I want to find the velocity at point A. That is velocity at t is equals to 0. Then in order to find the velocity at point A, I have to draw a tangent. Why I am drawing tangent? Let me explain. Since in XT graph, when we draw a tangent, the slope of the tangent gives us the velocity. Slope of the tangent gives us the velocity at that point. Gives us the velocity. So in order to get the velocity at this point A, I should find the slope of the tangent at the point A. So when I found that, when I drew a tangent, I found that the tangent is parallel to time axis. Hence, the slope of the tangent at point A is 0. So I found that the slope of the tangent at the point A is 0. Since the slope of the tangent at point A is 0, velocity at point A is also 0. Since I can conclude that at t is equals to 0, v is also equals to 0. So this satisfies the option A. So option A is true. Now coming to option B. Option B says that at B the acceleration A is greater than 0. So when I observe in the graph, first let me find the velocity at point B. So in order to find velocity, I will draw a tangent, and this tangent is also parallel to the time axis. Since the velocity at point B, okay, velocity at point B is also equals to 0 as explained before. So velocity vanishes at the point B, then acceleration at point B is also equals to 0. Since acceleration is equals to 0, option B says that acceleration is greater than 0 at point B, which is wrong. Okay. Now coming to option C. Option C says that at point C, the velocity and acceleration both vanishes. So let us find. So firstly try to observe the graph. Here we can observe that from B to C, the graph is decreasing, but at point C, you can slightly see that the graph becomes slightly horizontal. So at this point, at this position, the graph is slightly horizontal. When I draw the tangent to this uh, point, I will get the tangent is almost parallel to the time axis. So since the tangent is almost parallel to the time axis, I can write it as a velocity at c is equals to 0. Then and also acceleration at c is equals to 0. Since velocity is not vanishing at that point, then acceleration is also vanishes. So option C is also right. Okay. Next, coming to option D. In order to understand option D, first you should know what the average velocity is. Average velocity between AD they are asking us. Let us check whether it is positive or negative. Since we know the average velocity formula, final position minus initial position. Here you can see that the final position of the particle is here in this A to D scenario, in the A to D motion, we can see that the final position of the particle is xd minus initial position. The particle was started from rest at t is equals to 0, that is point A. So xd minus xa by delta t. Since we know the this point D lies on the time axis, here the displacement of the point D is 0. Okay, this point D, displacement of the point D is 0. Since as the displacement of the particle is 0 at D, 0 minus xa by delta t. And we can also see that this point A lies in the upward direction. So here the xa, whatever the xa magnitude you get, that is also always positive. So overall, when I talk about the overall magnitude, overall average velocity, obtained between AD is here negative. So option D is wrong because the option D says that the average velocity is positive, which is wrong. Now coming to option E says that the speed at D exceeds than E. So in order to understand that, first you should be familiar with the speed and velocity. Magnitude of velocity is nothing but speed. Okay, so when they are talking about the speed at D, it means that, indirectly means that they are asking us to find the magnitude at point D, magnitude of velocity at point D, magnitude of velocity at point D. In order to find the magnitude of velocity, first you should know how to find velocity in the xt graph. At point D, I can find the velocity by drawing a tangent. If I find the slope of the tangent, I will get velocity. So I need only magnitude because I have discussed about speed. So speed is nothing but magnitude of velocity. I need only mod of the slope at the tangent, mod of the slope at D, and mod of the slope at E. Slope at E. So when I compare both slopes here at point, when I compare the slope here and when I compare the slope here, I found that at point D, the slope is greater than the slope of the tangent is greater comparing to the point E. So since the slope at the point D is greater, slope of the tangent at point D is greater, the speed is greater at E. Speed at D is greater than speed at E. Hence proved. So our option E is also true. So option E is true.